September 6, 1976. A military airfield in Chuguyevka, deep in the Siberian wilderness. Lieutenant Viktor Belenko walks across the concrete apron toward his aircraft, a MiG-25 Foxbat interceptor. His boots echo against the tarmac. His flight suit feels heavier than usual. Beneath it, pressed against his chest, is the technical manual for the aircraft, a document so classified that possessing it outside secure facilities means immediate execution. He climbs into the cockpit for what his squadron believes is a routine training flight. He straps in, runs through pre-flight checks. His hands move through procedures he has performed hundreds of times. But today, everything is different. Today, Viktor Belenko will do something no Soviet pilot has ever attempted. He will steal the most secret fighter jet in the USSR and deliver it to the Americans. What Belenko knows, what the world is about to discover, is that the aircraft that has terrorized the West for 15 years, the interceptor that NATO analysts have called invincible, the jet that has shaped Western military doctrine and consumed billions of dollars in countermeasures, it is all built on a lie. But to understand why Belenko risked everything, why he chose certain death if captured over one more day in the Soviet Air Force, we need to go back 12 years. Back to 1964, when Soviet engineers were ordered to build the greatest fraud in military aviation history. The year is 1964. The Soviet Union is humiliated. For 4 years, American U-2 spy planes have violated Soviet airspace with impunity, photographing military installations, nuclear facilities, strategic positions. Soviet interceptors cannot reach them. Soviet missiles cannot hit them. The flights continue, brazen demonstrations that Soviet air defenses are obsolete. Then the Americans unveil something worse. The XB-70 Valkyrie, a strategic bomber capable of Mach 3, cruising at 70,000 feet, carrying thermonuclear weapons deep into Soviet territory. The Americans show footage of this massive aircraft, 6 engines, delta wings, a bomber that flies faster than any Soviet interceptor can chase. Soviet leadership panics. The technical specifications are terrifying. The Valkyrie will make Soviet air defenses irrelevant. Every city, every military installation, every strategic asset becomes vulnerable. The order goes out to the Mikoyan Gurevich Design Bureau. Build an interceptor. Build it fast. Build something that can destroy these bombers before they reach their targets. The specifications are impossible. The interceptor must fly at Mach 3. It must reach altitudes above 70,000 feet. It must carry long-range missiles capable of hitting targets from beyond visual range. And it must be in service within 3 years. The Design Bureau faces immediate problems. Creating an aircraft capable of sustained Mach 3 flight requires titanium. Titanium can handle the extreme temperatures generated by air friction at those speeds. Steel melts, aluminum warps. Only titanium works. But the Soviet Union lacks the industrial capacity to produce titanium in the quantities needed. Titanium fabrication requires specialized welding techniques, vacuum furnaces, skilled workers trained in exotic metallurgy. The Soviet aerospace industry has none of this at scale. The designers make a compromise. They will use steel. Specifically, a nickel-steel alloy that can tolerate high temperatures better than conventional steel. It is heavier, much heavier. It requires the aircraft to be massive to generate enough lift, but it can be welded by standard factory workers using conventional equipment. It is the only material available in sufficient quantity. The second problem is engines. No Soviet engine can sustain Mach 3 flight while remaining reliable. The solution is brutal in its simplicity. Engineers take the engine from a cruise missile, the Tumansky R-15, designed for a single high-speed flight before self-destructing. They modify it. They strengthen it enough to survive multiple flights. But the fundamental design remains, an engine optimized for short bursts of extreme performance, not sustained operation. The result is an aircraft that weighs 37,000 kilograms empty, one of the heaviest single-seat fighters ever built. The wings are small, optimized for high-speed flight, terrible for maneuverability. The fuselage is a long tube of welded steel plates, built in sections by factory workers who have never seen titanium. The cockpit instruments are pulled from bombers designed in the 1940s. The electronics use vacuum tubes, technology Western militaries abandoned 20 years earlier. On March 6, 1964, test pilot Georgy Mozolov takes the prototype into the air. The official report describes exceptional characteristics, unprecedented capability, a revolutionary achievement in Soviet aviation. What the test pilots say privately is different. They say it flies like a freight train locked onto rails. It accelerates in a straight line faster than anything in existence. But it cannot turn. It cannot maneuver. At Mach 2.8, pulling more than 2.2 g-forces in any direction risks structural failure. The entire airframe begins to twist, rivets pop, seams separate. But to Soviet planners, none of this matters. The MiG-25 has one mission: intercept American strategic bombers flying in straight lines at high altitude and high speed. Maneuverability is irrelevant. Dogfighting capability is pointless. The interceptor needs to fly fast, climb high, fire missiles at bombers from beyond visual range, then return to base. For that single mission, the MiG-25 is adequate. It can reach Mach 2.83. It can climb above 80,000 feet. Its radar can detect large targets at reasonable range. Against a formation of B-70 Valkyries flying predictable courses towards Soviet cities, it would be effective. Then, in 1969, the Americans cancel the B-70 program. They build only 2 prototypes. The bomber threat the MiG-25 was designed to counter never materializes. The United States decides strategic missiles are more effective than bombers. The Valkyrie dies before entering production. The Soviets have manufactured hundreds of interceptors for a bomber that will never threaten their airspace. They have committed enormous resources to countering a capability the Americans abandoned. The entire program is a response to a threat that no longer exists. But cancelling the MiG-25 program is impossible. Too much money has been spent. Too many factories are tooled for production. Too many political careers depend on the program continuing. So production continues. The Soviet Air Force receives interceptors optimized for a mission they will never fly against an enemy that will never come. And then someone in Soviet intelligence has a brilliant idea. If the MiG-25 cannot serve its intended purpose, it can serve another. It can become a psychological weapon. 1970. The first MiG-25P interceptors enter operational service. NATO intelligence detects them. Analysts see a large twin-engine fighter. They see swept wings. They measure radar signatures suggesting enormous power plants. Intelligence reports note the aircraft reaches speeds above Mach 2.5 and altitudes above 70,000 feet. NATO analysts make assumptions. They assume Soviet engineers used titanium, the only material that makes sense for sustained Mach 3 flight. They assume advanced avionics, sophisticated radar systems, cutting-edge electronics. They see the large nose and assume a powerful multi-mode radar, capable of tracking multiple targets. They observe the size of the engines and calculate thrust-to-weight ratios, suggesting exceptional maneuverability. Every assumption is wrong. But the Soviets do nothing to correct them. Instead, they feed the misconceptions. They allow controlled leaks. They release technical specifications that emphasize speed and altitude while remaining vague about limitations. They showcase the MiG-25 at air shows, flying carefully choreographed profiles that suggest capabilities the aircraft does not possess. At the 1973 Paris Air Show, a MiG-25 performs a display that stuns Western observers. The pilot executes what appears to be a high G turn at supersonic speed. Analysts calculate the G-forces involved and conclude the airframe must be extraordinarily strong. They publish reports describing a fighter with agility matching or exceeding Western designs. What they do not know is the pilot carefully managed his speed and angle to create the visual impression of a high G maneuver while keeping actual stress on the airframe within safe limits. The entire display is theater, designed to reinforce assumptions NATO analysts have already made. Soviet military journals publish articles praising the MiG-25, describing it as a triumph of Soviet engineering, superior to anything in Western arsenals. They provide just enough detail to seem credible, while omitting anything that would reveal actual limitations. The articles circulate in the West. Defense analysts translate them. The information feeds into NATO assessments. In 1973, Robert Seamans, Secretary of the United States Air Force, testifies before Congress. He describes the MiG-25 as probably the best interceptor in production in the world. American military planners design tactics and acquire weapons based on the assumption they will face an agile, high-performance fighter with advanced radar and long-range missiles. The deception works because it exploits Western analytical methods. NATO intelligence gathering is sophisticated. Analysts collect data from multiple sources, cross-reference information, build comprehensive assessments. But their conclusions are only as good as their assumptions. When the foundation is false, the entire analysis becomes false. Soviet pilots know the truth. They sit in cockpits with instruments that belong in museums. They fly aircraft with hydraulic systems that leak constantly, requiring ground crews to add fluid before every flight. They experience radar systems that struggle to distinguish aircraft from ground clutter. They feel control surfaces that require both hands on the stick to move at high speed. They read technical manuals that explicitly warn against maneuvering above 2.5 G at supersonic speeds. But they cannot speak. Criticizing Soviet military equipment means disloyalty. Suggesting Western aircraft might be superior means treason. Pilots who question official narratives find their careers ended. Some find worse fates, so they stay silent. They fly their training missions. They follow procedures. They pretend the aircraft is everything the propaganda claims. Viktor Belenko flies the MiG-25 for 5 years. He knows every limitation. He knows the radar cannot track fighter-sized targets beyond 50 kilometers. He knows the fuel consumption at low altitude is catastrophic, measured in minutes of flight time. He knows the engines require complete overhaul every 150 hours because the extreme temperatures degrade internal components. He knows that everything his commanders say about the aircraft, everything the propaganda declares, every claim made to justify the program is a lie. And he can tell no one. Until September 6, 1976, when he decides the lies must end. The morning of September 6th begins like every training day. The 513th Fighter Regiment receives its flight schedule. Multiple aircraft will conduct intercept training, practicing procedures for engaging high-altitude targets. Viktor Belenko is assigned to one of the formations. Everything appears routine. Belenko follows pre-flight procedures exactly. He does not deviate from protocol. He does not give any indication this flight is different from hundreds of others. He climbs into the cockpit of his MiG-25. Ground crew see nothing unusual. His squadron commander sees nothing unusual. The technical manual pressed against his chest remains hidden. He starts engines. He taxis. He takes off with the other aircraft in his flight. They climb to altitude. They begin the training exercise. And then, at the furthest point from the base, when he is supposed to turn back, Viktor Belenko does not turn. He pushes the stick forward. The MiG-25 descends rapidly. He levels off 30 meters above the Sea of Japan. At this altitude, he is below Soviet radar coverage. Ground controllers cannot track him, but flying a MiG-25 at low altitude is incredibly dangerous. The aircraft is not designed for this. Fuel consumption skyrockets. The engines, optimized for thin air at high altitude, gulp fuel in the dense atmosphere near sea level. His squadron mates realize something is wrong. They follow. They try to intercept. But Belenko has a head start, and at low altitude, with full afterburners, the MiG-25 is still the fastest aircraft in Soviet inventory. His pursuers cannot catch him before he crosses out of Soviet airspace. He flies toward Japan. Periodically, he climbs briefly to higher altitude, allowing Japanese radar to see him. He wants them to track him. He wants them to know a Soviet military aircraft is approaching. He does not want to be shot down by Japanese air defenses because they mistake him for a cruise missile or incoming attack. His fuel gauges drop rapidly. The MiG-25 carries enormous fuel load, but at low altitude with afterburners engaged, even that is not enough. He intended to land at Chitose, a Japanese military airfield he knows can handle large aircraft. But weather forces him to divert. He aims for Hakodate, a civilian airport on the northern coast of Hokkaido. As he approaches, a Boeing 727 is departing. The civilian airliner and the Soviet fighter nearly collide on the runway. The Boeing pilot executes an emergency climb. Belenko slams the MiG-25 onto the runway. He deploys the braking parachute. He stands on the brakes. The runway at Hakodate is 2,000 meters long. The MiG-25 requires more. He runs off the end of the runway. The aircraft plows 250 meters through grass before stopping. Japanese police arrive within minutes. They find a Soviet pilot standing next to his aircraft. His first words are simple. He wants political asylum in the United States. His aircraft has less than 30 seconds of fuel remaining. The Soviet response is immediate and furious. The Soviet ambassador to Japan demands the immediate return of the aircraft and the pilot. Soviet officials insist Belenko was disoriented, confused, that he landed in Japan by mistake. They claim he wants to return to the Soviet Union. They demand access to him. On September 9th, Soviet diplomats meet with Belenko. They have authorization to offer anything. They promise his family will be safe. They promise no punishment. They promise career advancement. They tell him his mother is sick, that she needs him. They employ every technique of persuasion and manipulation developed over decades of Soviet intelligence operations. Belenko refuses. His defection is intentional. He is not confused. He is not disoriented. He knows exactly what he is doing. He reiterates his request for asylum in the United States. President Gerald Ford grants asylum on September 10th. Belenko boards an American military transport and flies to the United States. He brings with him complete knowledge of Soviet interceptor doctrine, air defense systems, training methods, and most critically, detailed technical understanding of the MiG-25. But the aircraft itself remains in Japan. It is too large for Japanese cargo aircraft. The Japanese government wants it gone. The diplomatic pressure from the Soviet Union is intense. But before returning the MiG-25, the Japanese and Americans will examine every component. On September 25th, American technicians partially dismantle the aircraft. They remove the wings. They disconnect major systems. They load everything onto a C-5A Galaxy transport. Someone hangs a banner on the side of the aircraft. It reads, in Japanese, "Goodbye people of Hakodate. Sorry for the disturbance." The aircraft flies to Hyakuri Air Base. For the next 67 days, American and Japanese engineers conduct the most thorough analysis of a foreign military aircraft ever performed. They photograph every component. They measure every dimension. They weigh every part. They test every system. They disassemble the radar. They examine the engines. They analyze the steel composition. They evaluate the avionics. They document the weapons systems. What they discover destroys 30 years of assumptions. The fuselage is welded steel plate, gauge 18, the kind of material used in commercial construction. The welds are irregular, done by hand, showing the marks of individual welders. Rivets protrude from the surface, increasing aerodynamic drag. This is not advanced aerospace manufacturing. This is shipyard construction applied to an aircraft. The engineers find no titanium. The entire structure is steel and aluminum. The Americans had designed countermeasures assuming Soviet titanium fabrication techniques had matched or exceeded Western capabilities. The reality is, the Soviets never developed those capabilities at all. The electronics are antiques, vacuum tubes, technology from the Korean War era. The radar, designated RP-25 Smerch, is powerful but primitive. It can detect large targets at reasonable range, but its ability to distinguish targets from ground clutter is poor. Against formations of bombers, it would work. Against maneuvering fighters, it is marginal. The flight control systems confirm what Belenko told interrogators. At high speed, moving the control stick requires enormous force. The pilot must use both hands and significant upper body strength. Analysis of the hydraulic systems and structural loading limits confirms that maneuvering above 3G at supersonic speeds risks catastrophic structural failure. The MiG-25 can fly fast in a straight line. It cannot fight. The CIA produces a comprehensive assessment. The conclusion is devastating to 3 decades of Soviet propaganda. The MiG-25 is not the technological leap that NATO feared. It is a specialized tool, optimized for a single mission, built with obsolete technology because better options were not available. It is effective only against non-maneuvering targets flying predictable courses. Against anything else, it is vulnerable. Belenko's testimony provides operational context. He describes training that emphasizes rote procedures over tactical thinking. He explains fuel limitations that restrict flight time to minutes during combat operations. He details maintenance requirements that keep aircraft grounded more often than they fly. He describes a pilot training system that produces operators who can follow checklists but cannot adapt to unexpected situations. The revelation spreads through NATO military establishments. Tactical manuals are rewritten. Threat assessments are revised. Weapon systems under development are re-evaluated. Billions of dollars in countermeasures designed to defeat a capable Soviet interceptor become unnecessary. In the Soviet Union, the reaction is catastrophic. The 513th Fighter Regiment is disbanded. Every officer who knew Belenko faces investigation by the KGB. His wife and son are interrogated repeatedly, subjected to pressure to denounce him. Commanders are demoted or removed from service. New security procedures are implemented at every airbase. Pilots are forbidden from carrying technical manuals during flights. On November 15, 1976, the MiG-25 is returned to the Soviet Union. It arrives in 30 wooden crates. Soviet engineers inspect every crate. They discover that every component has been photographed, measured, and tested. Nothing remains secret. The Americans know everything. But while Soviet propaganda was constructing an illusion, American engineers were building something real. The origin of the F-15 Eagle begins in 1965, with the lessons of Vietnam. American fighters had been designed primarily for nuclear strike missions, optimized for speed and payload, not maneuverability. Against nimble North Vietnamese MiG-17 and MiG-21 fighters, American F-4 Phantoms struggled. Kill ratios that should have favored the technologically superior American aircraft were disappointingly low. The United States Air Force issues a requirement for a new air superiority fighter. The mission is simple: destroy enemy aircraft, not strike ground targets, not deliver nuclear weapons, just achieve and maintain air superiority in any combat environment against any opponent. McDonnell Douglas wins the contract. The chief engineer, Dave Lewis, assembles a design team with a single mandate. No compromises. Build the best air-to-air fighter possible, regardless of cost or complexity. Every design decision will prioritize combat effectiveness. The result first flies on July 27, 1972. The F-15 Eagle is powered by 2 Pratt & Whitney F-100 turbofan engines, generating 21,600 kilograms of thrust. The thrust-to-weight ratio exceeds 1:1. The aircraft can accelerate straight up. The wing loading is 54 pounds per square foot, enabling sustained 9G turns at combat weight. But the real revolution is the radar and avionics. The Hughes APG-63 radar can track multiple targets simultaneously beyond 160 kilometers. The pilot sees a tactical display showing every aircraft in a battle space, friendly and hostile, with range, altitude and vector information updated in real time. The weapon system integrates radar, missiles and fire control into a seamless interface. The flight control system gives the pilot complete authority at any speed. Hydraulic actuators provide smooth, responsive control from subsonic to supersonic speeds. Electronic stability augmentation prevents departures from controlled flight. The pilot can maneuver at maximum G loading from sea level to 60,000 feet without fear of losing control. Test pilots describe the experience as revolutionary. In 1973, Irv Burrows demonstrates sustained 9G turns at 30,000 feet. The aircraft accelerates from Mach 0.9 to Mach 2.3 in under 2 minutes. Zoom climbs reach 65,000 feet. Every performance parameter meets or exceeds specifications. Captain Roger Wells, a Vietnam veteran with 2 confirmed kills flying the F-4 Phantom, transitions to the F-15 in 1974. After his first training mission, he tells instructors that any enemy pilot who faces this aircraft is already dead. The technological gap is too wide. The performance advantage is too great. The radar gives American pilots complete situational awareness. The missiles give them long-range kill capability. The maneuverability gives them dominance in close combat. There is no scenario where an F-15 should lose to any existing Soviet fighter. Soviet intelligence monitors F-15 development closely. Reports describe performance characteristics that seem impossible. Engineers conclude the Americans are exaggerating. No fighter can simultaneously optimize speed, maneuverability, and endurance. Something must be sacrificed. The Americans must be inflating capabilities for propaganda purposes, just as the Soviets do. They are wrong. Every claim about the F-15 is conservative. The actual performance exceeds published specifications. December 10, 1976. The first F-15A Eagles arrive in Israel. The Israeli Air Force designates them Baz, meaning Falcon. The timing is significant. 3 months after Belenko's defection revealed the truth about the MiG-25, Israel receives the weapon designed to counter it. Israeli pilots undergo intensive conversion training. The Israeli approach to air combat is aggressive and opportunistic. Pilots train to exploit every advantage. They practice engagements against their own Mirage fighters and against A-4 Skyhawks simulating enemy aircraft. They fly combat training until the aircraft's capabilities become instinctive. Colonel Benny Peled, an Israeli test pilot, summarizes the impact. The Eagle gives Israel a 20-year technological lead over any potential adversary. The radar can track Syrian fighters taking off from Damascus, while Israeli aircraft orbit over Israeli territory. The missiles can engage targets before enemy pilots know they are under attack. The maneuverability means any close-range engagement favors the Israeli pilot. But Israeli intelligence still considers the MiG-25 a threat. Syrian reconnaissance variants overfly Israeli positions with impunity. They fly too high and too fast for Israeli interceptors or surface-to-air missiles. These flights are demonstrations of Soviet superiority, reminders that Israel cannot control its own airspace. Israel receives the complete CIA assessment of the captured MiG-25. They know it is vulnerable, they know its limitations, they understand how to exploit them, and they wait for the opportunity. On February 13, 1981, a Syrian MiG-25 reconnaissance aircraft flies over Lebanon. The mission is routine. Syrian pilots have flown these missions dozens of times. They believe they are invulnerable. Soviet instructors trained them that nothing can reach a Foxbat at high altitude and high speed. The Syrian pilot cruises at 28,000 feet at Mach 2.35. His radar warning receiver is silent. He has no indication of threat. He follows the standard profile, straight and level, gathering intelligence on Israeli positions. Below and behind him, Israeli pilot Benny Zinka tracks him on radar from 90 kilometers away. The APG-63 radar maintains perfect lock despite the target's speed. Zinka positions his F-15 in the Syrians' radar blind spot, below and behind, outside the detection envelope of the MiG-25's rearward-looking systems. At 35 kilometers range, still beyond the Syrian radar's ability to detect a fighter-sized target, Zinka launches two AM-7 Sparrow missiles. The missiles accelerate to Mach 3.5. They close on a supersonic target in seconds. The Syrian radar warning receiver, designed to detect threats from ahead, indicates nothing. The first Sparrow detonates 6 meters from the left engine. Shrapnel destroys the engine and punctures fuel tanks. The second Sparrow enters the debris cloud and detonates near the cockpit. The MiG-25, traveling at 2,800 kilometers per hour, begins to tumble. The steel structure, never designed for violent maneuvers, twists and fails. Sections of the tail separate. The canopy explodes away. Ejecting from an aircraft rotating at Mach 2.35 exceeds the design limits of the ejection seat. From initial radar contact to destruction, 37 seconds. The Israeli pilot never enters visual range. The Syrian pilot never knows what hit him. Soviet instructors promised their students nothing could catch a foxbat at altitude and speed. They were wrong. June 9, 1982. The Bekaa Valley in Lebanon. Israel launches Operation Mole Cricket 19, an attack on Syrian surface-to-air missile batteries. 19 batteries, equipped with Soviet SA-6 and SA-8 systems, are positioned to deny Israeli aircraft access to Lebanese airspace. NATO considers these systems highly effective. Soviet advisors consider them impenetrable when properly deployed. Israel destroys all 19 batteries in less than 2 hours. Israeli losses, 0. The Syrian Air Force responds. MiG-23 floggers, MiG-21 fishbeds, and MiG-25 Foxbats scramble from bases around Damascus. Formations coordinate their approach. They follow Soviet tactical doctrine. They have numerical superiority. Soviet instructors trained them. Soviet equipment arms them. They fly toward the Bekaa Valley to engage the Israeli strike packages. Israeli F-15 pilots, orbiting in combat air patrol, track the Syrian formations on radar while the Syrian aircraft are still over Syria. The APG-63 radar displays multiple targets, their altitudes, their vectors, their speeds. Israeli pilots select targets, assign weapons, coordinate engagement sequences. The Syrian pilots see their wingmen explode without warning. Radar warning receivers provide no alert. They do not see the missiles. They do not see the Israeli aircraft. They see death arriving from nowhere. Moshe Melnik tracks 4 MiG-21 fishbeds in formation. He launches 4 Sparrow missiles in 12 seconds. 4 Syrian aircraft disintegrate. The Syrian formation breaks, pilots scattering in panic. But the Israeli radar tracks them all. More missiles launch. More Syrian aircraft die. Relik Shafir scores 5 kills in 2 separate engagements the same afternoon. He describes the experience as clinical rather than dramatic. The radar identifies targets. The fire control system computes solutions. The pilot confirms authorization and launches weapons. The missiles guide to impact. Procedures, not heroics. By sunset, 82 Syrian aircraft have been destroyed. Israeli air-to-air losses, 0. 82-0. The most one-sided air battle in the jet age. Marshal Pavel Kutakov, Commander-in-Chief of Soviet Air Forces, flies personally to Syria. He inspects bases. He interviews surviving pilots. He reviews engagement data. His report to the Ministry of Defense is classified top secret. The conclusion is stark. Western technology has achieved superiority that Soviet systems cannot contest. The gap is not incremental. It is generational. By the end of June, Israeli F-15s have achieved 58 confirmed kills against Syrian aircraft without a single air-to-air loss. January 19, 1991. Operation Desert Storm. Iraqi pilots attempt to intercept coalition aircraft. Captain Rick Tolini, callsign Sitgo-21, flying an F-15C, engages a MiG-25 attempting to climb toward coalition strike packages. He launches an AIM-7M Sparrow. The missile guides perfectly. The Iraqi MiG explodes. Minutes later, Captain Larry Pitts, Sitgo-22, destroys a second MiG-25 with identical tactics. Long-range detection, missile launch beyond visual range, perfect guidance, destruction. Within 72 hours of the war beginning, coalition forces achieve total air superiority. Iraqi fighters that attempt to engage are destroyed. Iraqi fighters that remain on the ground are bombed. By the third day, Iraqi pilots choose to fly their aircraft to Iran rather than face certain death. The final accounting is simple and brutal. The MiG-25 Foxbat, in its entire operational history, achieves 0 confirmed air-to-air victories against Western fighters. It suffers dozens of losses against F-15s, F-16s, and other Western aircraft. The aircraft built to terrify the West becomes a symbol of Soviet technological failure. The F-15 Eagle achieves 104 confirmed air-to-air victories. It suffers 0 losses in air-to-air combat, 104-0. The kill ratio is perfect. The MiG-25 cost approximately 1/3 what an F-15 costs. By simple mathematics, the F-15 is worth 30 MiG-25s in combat effectiveness. The American investment in quality over quantity proves correct. One technologically superior fighter defeats multiple inferior opponents. A Soviet military report prepared in 1988 for Marshal Shaposhnikov, declassified after the Soviet collapse, states the conclusion Soviet military leaders refused to admit publicly. Soviet tactical aviation is 15 to 20 years behind American capabilities. The gap is widening. Closing it will require complete restructuring of design philosophy, manufacturing capability, and operational doctrine. Viktor Belenko lives quietly in the United States. For years, he works as a consultant on intelligence and defense matters. His expertise on Soviet systems and tactics proves valuable throughout the remainder of the Cold War. His defection changed the course of military history. One man with 30 seconds of fuel, landing at a civilian airport, revealing the truth about 30 years of lies. Alexander Zuyev, a Soviet pilot who defects in 1989 flying a MiG-29 to Turkey, provides additional context. He says Soviet pilots knew the F-15 was superior to anything in Soviet inventory. Every pilot who studied engagement reports from Israeli operations understood this, but Soviet doctrine insisted individual quality did not matter because Soviet forces had numerical superiority. It was a lie told to maintain morale. Zuyev describes the MiG-25 as a propaganda weapon disguised as a fighter. Its purpose was intimidating the West, not winning wars. When Belenko delivered a complete aircraft to the Americans, the deception died completely. After that, the Foxbat became an embarrassment. The Soviet Air Force continued flying because scrapping it would publicly admit failure. The F-15 Eagle remains in service. American, Israeli, Saudi, and Japanese air forces continue operating the type. The latest variant, the F-15EX, represents continuing evolution of a design now 50 years old. Total production exceeds 1,500 aircraft. No replacement is in sight. The jet designed in the early 1970s to counter the MiG-25 remains effective in the 2020s. The MiG-25 served in limited numbers until the early 2000s, primarily in reconnaissance roles. Its career as a combat fighter effectively ended on February 13, 1981, over Lebanon, 37 seconds after Beni Zinka launched his missiles. Marshal Kutakov, investigating the disaster of the Bekaa Valley, told his staff the truth. Soviet leadership refused to acknowledge publicly. The Soviet Union spent 30 years building the wrong air force. They optimized for the previous war, building interceptors to stop bomber formations that would never come. The Americans prepared for the next war, building fighters designed to dominate any combat scenario. A 30-year-old Soviet pilot with 30 seconds of fuel remaining, landing at a civilian airport in Japan, demonstrated that 30 years of Soviet propaganda was exactly that: propaganda. The myth of the MiG-25 died in Lebanese airspace on a February afternoon in 1981. But the truth was already known. It was revealed 5 years earlier by one man who could no longer live a lie. Belenko showed the world that the most fearsome weapon is not the one that inspires,